Binary distribution is what we are going to cover in this lesson. It's sometimes known as the binary distribution. This is an example of discrete probability distributions, and this is a distribution that has only two possible outcomes. Now, unlike other probabilities, we've seen that you cannot predict the outcomes that you are going to have. But this one specifically, we have only two possible outcomes. One what we call the probability of success, and another we call the probability of failure. If x is a random variable that follows a binary distribution, then this I write it that x follows a binomial with n, the number of trials, and p, the probability of success. So let us see the properties of this binomial or the binary distribution. It should have repeated number of trials. This repeated number of trials in that experiment you are carrying out, you denote them with by the letter n. Each trial should have only two possible outcomes. Then I the success and the failure. What do we mean by saying two possible outcomes? Now, like when someone is pregnant, you know that there are only two possible outcomes. Either she delivers a boy or a girl. So those are two possible outcomes there. There is no any other outcome. Except the idea of getting twins and so on. But without that, there are only two possible outcomes. Leave alone the things, someone who produced what, but there are only two possible outcomes. Either you produce a boy or a girl. So those are the two possible outcomes for a normal delivery of one kid. Then the number of trials are independent, i.e. each trial has no effect on the other. When you throw, for example, when you throw a coin, you expect either a head or a tail, as simple as that. But when you throw that coin again, the first doesn't affect the next throw or the next outcome that you are going to get after throwing it. So that's what we mean by independent. The probability of success is the same in all trials. So you distribute my probability of success in this trial is this. As simple as that. In a binomial distribution, n is the number of trials, p is the probability of success, then q is the probability of failure. And always when we add the probability of success plus the probability of failure, we get a 1. So the probability of success and failure change depending on the experiment carried out. So depending on the experiment and what your aim is what you use to define the probability of success and failure. So, if you have one, you can get the other because you can just make one the subject. If you have one, you can get the other. So, for a binomial distribution, followed by this, so for probability, this is what we call the exact probability. When x is equal to 2, small x is given by this. This is why now, this is what we are going to use when calculating this method here, I mean this formula here for a binomial, for exact results. This is what we use. We are going to see that we can read off these values from a table. Okay, so the mean of a binomial distribution is given by NP. We have seen this number of trials. This is probability of success. Then the variance of this is given by NPQ. We know what Q is, and N. Then the standard deviation is as simple as getting the square root of the variance, which will be NPX, square root of NPX. And when we come to mod of a binomial, this is the value of x that is most likely to occur. That when you do something, this is most likely to happen. And it's always the value with the highest probability. That it occurring is very, very much possible. That's why the lower the probability, the less the chance of that thing occurring. But the higher the probability, the most likely for that something to occur. To obtain more, we calculate the mean and know why the value of x above the mean is one with the highest probability, and hence becomes that value of x becomes our mod. We are going to see how we get this in our next examples in the next lesson. Common ones in the binomial for x in an experiment with 4 trials, the probability of x this is that, not with, the probability of x, that, the probability of x, that, x exactly 2, exactly 2. This one now we shall use this formula. This I write exactly 2. More than 2x greater than 2. Now, greater than 2, it means something above 2. Above 2, we are dealing with the integers. There is 3, there is 4. Why are we stopping at 4? Because we had only 4 trials. Then less than 2 means that figures below are 2. Can get 1 and then 0. We already deal with positive integers, positive whole numbers. So that's why we have a 0 so and then 1. At least 2, at least means greater or equal. So greater or equal 2 means that we are including also 2. That's why we have greater or equal to, we have 2, 3, and 4. I'm stopping at 4 because we have 4 trials only. At most 2, at most means the highest should be 2. That's why I say from 2 to 1 up to 0. 1x greater than 1 but less than 4 means that the value in between. Greater than 1, we have 2, 3 but less than 4. That's why we are stopping at 3. Greater than 1 but less or equal to 4. Now this one here, we want this value of 4. That's why greater than 1, we have 2, 3. Even if it's greater than 1, but should be less or equal to 4. That's why we are stopping at that. Then this one is telling us greater or equal to 1 but less than 4. Greater or equal to 1 start from 1, 2, 3. We are not including the 4 because it should be less than 4. We are going to see more of this when we have when this is greater or equal to and this one is less or equal to. And then we'll see some examples in the next lesson. I wish you